So we're going to have a look at the BGS, the British Geological Survey map of the bedrock geology of the UK South, and that means England and Wales, most of England and Wales. But actually I'm going to just focus on the south of England. But to understand the south of England, I think if you look at this, you can see there's a story here. What's this line going from northeast to southwest? Let's try and understand what we're looking at here. There is an index, so let's start off over there to see what all these colours represent. So at the top you have the younger rocks, and as you go down through this column you get right down to the oldest rocks. So if you can try and remember those colours, we've got these blues and these purples at the bottom. Those are the older rocks, and at the top we've got these colours. And that's always the way that geological maps show the rock strata, with the young ones at the top. And that's logical if you think about it, because the young rocks are laid down last. They will be at the top, and if you dig down and down underneath the young ones, you'll go deeper to find the older ones. Well, let's have a look again at the colours, and in particular at this succession of colours going from east to west. And I say from east to west because if you remember those colours, the young colours are in the east, the old colours are in the west, in fact in Wales here. So what I'm going to do is try and understand why there is this progression in age from east to west, or starting with the older ones from the old ones in the west across the country to the younger ones in the east. And I'm going to do a little bit of investigation to see what could have caused that. But just to point out this very distinct line here, this greenish yellow colour is representing the chalk, and you'll know the chalk if you think about the south coast of England. You'll have seen the White Cliffs of Dover, for example, or Beachy Head, and that's where the chalk reaches the coast and is exposed at the coastline. That chalk, you probably know, continues in France. If you go across from the White Cliffs of Dover, they've got very similar cliffs on the other side of the English Channel, and if you follow the chalk this way, you can find the same rocks extending for hundreds of miles across into Europe, into Germany. So that's telling a story of rocks laid down through the ages, and in a sequence of rocks which goes from old in the west to younger and younger and younger and younger in order of that sequence to the youngest rocks in the east. Mostly. You can see a few bits of exceptions there. But there's the first puzzle, is why is that? So why do we see the old rocks at the surface in the west and not any of these younger rocks on top of them? And the second question is, how come the mountains are on this side? The old rocks are much, much higher in elevation than the young rocks. I can never really quite work that out. How did the old rocks get to be higher than the young rocks? Because over this side, if you dig down deep underneath the younger rocks, you can find the older rocks right underneath, deep down. So how did that happen? Now I've got here some layers of things which I've collected from around my house, which are going to represent the different rock layers, the strata that we find across southern England. and I've started to lay them out here. Whichever layers are at the bottom, those must be the oldest ones because they've been laid down first. And so as more and more layers are arriving on top, these must be younger rocks than the ones that are underneath. So let's imagine through the ages we've got more and more rocks piled on top, maybe finishing with a nice big thick band of chalk. That's going to represent chalk, and perhaps a bit of London clay on top of that. So we know that if I'm in the east, I'm going to say the east is over here, and I'm in London, I know I've got London clay with chalk underneath. I can even see it outcropping at the surface nearby. But also if there are engineering projects where people have drilled down deeper, they know that they can find these older rocks underneath the chalk. So it's safe to say that the strata exist all the way across the country. But what we see is in the east, all of them with the old rocks buried very deep underneath. But in the west we don't see that at all. In Wales, in fact, what we see is the older rocks at the top, at the surface, with none of the younger rocks on top. So the first question is, where have all those young rocks gone? But the bigger puzzle to me is, how could the old rocks be at such a high elevation? Those are mountains in Wales in the west. Those are 700 or 800 meters above sea level, while these younger rocks in the east are never more than about 300 meters above sea level. So how does that work? And well, the obvious thing is these must have been lifted up something like this, and I guess we can replicate a bit of lifting and keep going and keep going until we can see that in fact if it ends up something like this, we would have the old rocks in the west at a higher elevation than the young rocks in the east. So far so good, that must be what happened. But there's the question now, what on earth made these rocks lift up so high in the west of England or Wales? In fact, only in Wales. England probably cuts in about here. What could have caused this huge amount of uplift? So that's the question. I don't know the answer to that. I'm going to have to go off and look it up and see what I can find out about what could have caused the western part of Britain to be so much higher than the eastern side.